Okay, so your lesson for tonight is called writing functions. Basically, it's just all about using functions. And so let's go, take some notes on it. Okay, here is your vocabulary, only two words, independent variable and dependent variable. Okay, it's pretty self-explanatory that the dependent variable depends upon the independent variable. Okay, basically that's what I want you to take, is that the dependent variable depends upon depends on the independent variable. Okay, so in every function there'll be two variables, and we're trying to decide which one is the independent and which one is the dependent. Okay, so here's three examples that we're going to talk about. It says identify the independent and the dependent variables for in each situation. So in example A, it says in the winter more electricity is used when the temperature goes down, and less is used when the temperature rises. Okay, so in this example, the electricity depends upon the temperature. So we would say this, that the amount of electricity used depends on the temperature. The dependent variable is the amount of electricity, and the independent variable is the temperature. Okay? On the second example, read it and decide what you think is dependent and which one depends upon the other. It says the cost of shipping a package is based on its weight. Okay, so the cost in this problem depends on the weight. The cost of shipping depends on the weight. So another way to write that is here. The cost of shipping a package depends on its weight. The dependent is the cost, and the independent is the weight. The third one is probably the hardest one, and it says the faster Ron walks, the quicker that he gets home. The faster that he walks, the quicker that he gets home. So basically his time in getting home is dependent upon the speed that he walks. Okay, the time is dependent upon the speed. Okay, so the time is the dependent and the speed is the independent. Okay? All right. Probably the most practical thing we're doing this entire unit is talking about evaluating functions. Okay? Evaluating functions. And so we introduced yesterday what's called function notation, and that's where we have an f of x is equal to 5x. Okay, so our f function is this right here, f of x equals 5x. And it wants us to evaluate when x is 6 and when x is 7.5. So what we do is we plug those two values in separately for x. So the very first problem will look like this. F of 6 is equal to 5 times 6. Okay? Everywhere that there's an x, we plug in a 6. So the answer here is f of 6 is equal to 30. Okay? Several of you will just put 30, and that's okay. All right? The next example here would be f of 7.5. So we plug 7.5 into the same equation, 5 times 7.5. Everywhere that there's an x, we plug in a 7.5. So 5 times 7.5 is 37.5. So I would say this, f of 7.5 is equal to 37.5. And that will be our answer for the second part right there. Okay, I want you to try B, and then we'll go over it. Okay, so for B, I have a little bit bigger of a function. We'll call this one the g function. Okay, and now it has a t instead of an x, but it's the same basic idea. Okay, it says what is the g function when t is 2, and what is it when t is negative 5? So we plug it in for both of them. We say g of 2 is equal to 2.3. 0 times 2 plus 10. And we saw this would be 4.6 plus 10, which is 14.6. So our answer here would be g of when t is 2, g of 2, or the g function, is 14.6. Okay? The second equation, it says when g is 5, so we put g of 5 equals 2.30 times 5 plus 10. Okay? And 2.3 times 5 is 11.5. and then I add 10 to it, so I get 21.5. So my answer here is g of 5, and t is 5, and the g function will be 21.5. So that will be my answer for the second part of that function, okay? The last thing, and we'll do more of these tomorrow in class, is writing functions. And this is a little bit more difficult. We'll do these in class if you don't understand them on the video, okay? It says determine a relationship between the x and the y values, and then write an equation, okay? So we want to figure out what's the relationship between these two. What's the relationship between these? We want to look at this problem and see what is the relationship between all the numbers, basically. The x's are going up by 1. The y's are going up by 1, okay? The relationship between the x's and the y's is it's subtracting 2, isn't it? 2 minus 2, 0, 3 minus 2 is 1, 4 minus 2 is 2, okay? So here, what I want to do is I want to write an equation. So here my equation would be this, that y is equal to x minus 2. And that would hold true. That would hold true for each x and y value, correct? If I plug in 2 for x down here, 2 minus 2 is 0. If I plug in 3 for x right here, 3 minus 2 is 1, okay? So this would be the equation, but I want to write it in function notation. So I change the y to an f of x. I say f of x is equal to x minus 2. Okay? The next equation. I want to know what is the equation, the next function. I want to know what's the relationship here between the x's and the y's for each one. What's the relationship? I notice the x's are going up by 1s. The y's are going up by 3s. Okay? The y's are going up by 3s. Okay? And I've done this enough to know that if it's going up by 3s, then I'm going to multiply 3 by x. Okay, I'm going to say y equals 3 to x, but that doesn't work. So I'm going to guess around and say that I'm going to put a plus 1 in there. And let's see if this works. If I plug in 1, I'll plug in 1 for x, I will get out 4. If I plug in 2 for x, I will get out 7. So on and so forth. And it will work for each of them. Okay, so this is the equation that I would get. Okay, and I'm going to change the y to a function notation. F of x equals 3x plus 1. Okay, so that is the function I will get for example 4. Okay, last example is down at the bottom. It's hidden, and it's example 5. It says a mail order company charges $5 per order plus $2 per item in the order, up to a maximum of 4 items. Write a function to describe the situation. Find the reasonable domain and range for the function. Okay, so quickly, I just want to point out that it says $5 per order plus $2 per item. Okay, now we're only making one order, so I can really scratch out this per order part right there and just say charges $5 plus $2 per item, and it says a maximum of 4 items. So my function here, and we'll do this more tomorrow, is this: f of x is equal to $2 per item plus $5 for the whole order. So this will be my function, okay? $2 per item, so multiplied by the x, and then it's adding a $5 charge, up to a maximum of 4 items. So, okay, so that's my function, and then a reasonable, this says find the reasonable, excuse me, let me fix that. Find a reasonable domain and range. So a reasonable domain, or x values that I could plug in. The reasonable domain here is this: 1, 2, 3, and 4. Why is that reasonable? That's reasonable because it says a maximum of 4 items, okay, that I would be shipping or ordering. Okay, so I would only order 1, 2, 3, 4 items, somewhere in there. Okay, and then a reasonable range would just simply be the outputs for each one of those inputs. So when I plug in 1 into here, I'll get 2 plus 1, 2 plus 5 is 7. When I plug in 2, I'll get 9. When I plug in 3, I'll get 11. and 13. Okay, so that is a reasonable output, probably for price of the shipping. Okay, so those are the examples I want you to know for tonight on your video.